Hello everyone. Today we're going to talk about selection sort. So the way that selection sort works is picking the value that is minimum and put it at the very left side of the array. And then from the rest of the array that is remained, you pick again the minimum number and just put it at the like after the minimum number that you found. So you are repeating this until you like to check all the numbers, and then you are done with sorting. So on the board on the right side, you see the pseudocode for the selection sort. As you see, we're starting with the index I equal to 0. Then we are assuming that the first number is the minimum. So we are putting the minimum index equal to I, that in this case is equal to 0. Then we are starting with the next numbers that starting with I plus 1. So ij is equal to I plus 1, and it goes up to the end but not n including. So then we are comparing the any item that we have that j goes from. Let's show it here. So we're assuming that the minimum is the number at location 0, that's 7. And then we're comparing with the rest of the array and see that which value is minimum. So here the 3 is not is less than 7, so j will update the minimum, so minimum will be now 1. 2 is less than 3, okay, so now the minimum will be the index 2. So after we are done, okay, because 9 is not less than 2 and 4 is not less than 2 and also 8 is not less than 2, so we don't have any change on minimum. So minimum will be 2, okay, so the mean will be 2. And what we're going to do is we are swapping the value at a minimum and also the minimum at and also the array at location I, that I here is equal to 0. So swapping those values, we are putting 7 here and write it here. Okay, so we have number 2, number 3, 7, 9, 4, and 8. Okay, so also let's write it here. So minimum will be equal to 2. That is the index, not the value. Now we are increasing I, so I becomes 1, and we're starting from j equal to I plus 1. And the reason that we are starting with I plus 1, okay, and not from 0 is because we already put the I number at its location. So I was 1, I is now 1, so it means that we put like one number at its location, that is 2. So now the next, we're gonna find the next minimum number. In this case, so minimum will be equal to 1. Okay, so the minimum minimum will be equal to 1. And because 7, 9, 4, and 8 are not less than 3, okay, so there's no change in the minimum. So also the swapping doesn't do anything because the 3 and 3 are like at the same values. So there's no changes here, and 3 is at its location. Next round we have the I equal to 2, so it means that minimum will be 2. Then we're having 7, 9 is not less than 7, 4 is less than 7. So we are updating minimum, and minimum now gonna be 4. And then we have 8, that 8 is not less than 4, so we are not changing the minimum index. Then we are swapping the a location I with a at location minimum. And let's also write I, so I was 2. So now we're swapping this 4 with 7 here we have. So 4, and now this will be 7. Next, I becomes 3, so minimum index will be 3. And now we have 9, and we're comparing with 7, and 7 is less than 9, so we're updating the minimum index, so it's gonna be 4. And we have 8 that is not less than 4. So now we are swapping the value at location 3 with a array at location 4. So here is going to be 9, and this will be swapped with 9. That's going to be 7. Then I becomes 4, and so also we are putting the minimum to 4. Now we are going to have this item 9 and 8. And because 8 is less than 9, so minimum will be 5 now. And at the end, because there is nothing remains, so we are now swapping these two numbers. So here, this is going to be 9, and this is going to be 8. And as you see, the array is sorted. So that's a selection sort. 2, 3, 4, 7, 8, and 9 numbers are sorted. And as we said, at every iteration, you are picking the smallest number and put it in the left side of the array, okay? And you are doing like repeating this process for the for that part of the array that is not sorted yet. So you may ask that what's the time complexity of the selection sort? Okay, if you look at the for loops that we have here, so we have one for loops that goes from I equal to 0 to almost n, okay, and we have another one that goes from j equal to I plus 1 to n. Okay, together we'll have n multiplied by n, so it's gonna be the big O notation of n squared. Okay, so that's gonna be the like the worst case for the selection sort. Also, the best case and average case for the selection sort is also n squared, okay, because we need to check this condition here for like for I plus 1 to n. So that's going to be the discussion for selection sort.